So looking at section 12.4, we're looking at what's called combinations and permutations. These are very similar to each other, which tends to make this section a little bit more difficult than others. It's actually very simple once you just decide, is this scenario a combination or a permutation? Because all you have to do is put the two numbers into your calculator, you get the answer. Very, very, very simple. The difficult part is deciphering between knowing which scenario is which. So we're going to be spending these 4 slides to determine that. So here's your first situation. If you don't have the notes printed out, here's what you need to have written down. We have 3 flavors to pick from. We have a coupon for 2 scoops. So here's what we need to do. Determine all of the different 2-scoop ice cream cones you can order. What I want you to do on your own is to actually write out all of the different combinations that you can make of ice cream cones. So on your paper, right now, I'm going to give you some time to do that. Write down all the different ways that you can make an ice cream cone with those 3 options of flavors. All right. So hopefully you've come up with all of your different options, and your neighbor may have a different grand total number than you, which happens every single year that we do this section. So, and that's actually a really good discussion point. So hopefully, I'm hoping that not all of you have the same answer and that there are some varying answers. So when we're looking at this, there's many different ways to look at it. We could have these choices of vanilla, chocolate, strawberry vanilla, and strawberry chocolate. And you could say there's only 3 ways to make this ice cream cone. Others may say that it's different if you have vanilla first, then chocolate, and chocolate first, then vanilla. Similarly, we have these options. So we have either 3 as an answer or 6 as an answer. So one of these answers is the combination answer, and one of the answers is the permutation answer. Again, like I said, the most difficult and the only difficult part about this section is just deciding, is this a combination or a permutation? So here is the difference. If you could write these 2 words down, we'll get a quick definition. And by quick, I mean very quick. Permutations, order matters. Combination, order doesn't matter. So looking at our ice cream problem, the one on the left is saying that there's only 3 ways to make this ice cream cone, because to me it doesn't matter if the chocolate is on top or on the bottom. So this is a combination. This is a permutation. Because this person is saying that it matters whether or not the vanilla is first or second. So I'm going to count all of the cases. So that's a permutation because the order of them makes it a whole new case or a whole new ice cream cone. The difficult part about determining whether it matters or not is students tend to overthink these problems. So they're looking at this situation, or they look at a situation of going to Subway and getting a BMT, and you get ham, pepperoni, and salami. Well, regardless of the order that you put those different types of deli meat on the sandwich, it's still going to taste like a BMT. Kids will get into the argument, the unnecessary argument of saying, well, I like to make sure that the ham is the one on top. It doesn't matter. That is a combination problem. A sub sandwich is a combination problem because the order of the ingredients does not matter. If you're lining things up in a bookshelf, if they specifically say how many different ways can you order these things, then the order is going to matter. So you have to look for clues in the problems in order to figure that out. So, looking at this question, which one is always going to have more choices? Well, as you saw in the previous example with the ice cream cones, combinations had 3, permutations had 6. So the answer would be permutations are always going to have more, quite a bit more. So we're going to jump back to here because we're going to look at a button on your calculator that will find these answers for you. So if everyone could get your calculator out. You are looking for buttons that look like NPR and NCR. You're probably going to have to hit the PRB or probability button and scroll over in order to find them. Some of you will have them above one of your buttons, and others of you, like I said, are going to have to hit that probability button. So locate those buttons, and here's how you use them. So our situation, we had 3 choices for flavors. So that is the first number. And we had to select 2 of them. So they're going to give you a grand total of items that you're choosing from, and then how many that you need to pick for the problem. They'll always give you those 2 numbers. This will tell you the answer. So here's how you enter it into your calculator. You're going to put a 3 first, then your NPR button, and then a 2, and hit equals. You should get 6 if you entered it correctly. So I would write that down just to make sure that you remember how to enter these into your calculator. The combinations are entered the same way. We have 3 choices of flavors. It's a combination, and we're picking 2. So again, you're going to enter a 3, then your NCR, then a 2, and it will equal 3. And we're going to use this on the examples that we're going to go through in a moment. But just so you know, as soon as you figure out which one it is, permutation or combination, you're literally just putting the 2 numbers in your calculator and it will tell you the answer, instead of writing out all of these different options like you did with chocolate and vanilla and strawberry. So going back to here, let's figure out what happens when we increase the options. So let's try looking at an ice cream cone that has 3 scoops and we have 4 choices of flavors to choose from. So again, we decided that this scenario, because it's an ice cream cone and it truly does not change the ice cream cone, the order that you put them in, the order does not matter. So because the order does not matter, we are going to use a combination of 4 options, choosing 3 scoops. So if you go into your calculator, we're going to do 4 NCR 3, and we get 4 different ways to make that ice cream cone. Now, just so that we can practice using our calculator, let's say that the order did matter on this ice cream cone. How many choices would we have? Well, we would have 4, permutation 3. And if you put that into your calculator, you should get 24. So that increases it quite a bit. Now let's say we had 10 flavors and we get to have 7 scoops, or there's 10 options of deli meat, or 10 options for pizza toppings, and you get to pick 7 of them. How many different pizzas could you make? Any of these scenarios would work in this situation, combination. So put in 10, NCR, 7. There are 120 different ways to do that. So on the last slide, I'm going to give us some scenarios, some word problems. We just have to figure out, is this a combination or a permutation? Put it in the calculator, you get your answer. So the debate going on in your head, the math, the thinking, the logic that you're doing is figuring out which button am I going to use, NCR or NPR. So let's take a look at these scenarios. So I'm going to give you some time to write them down as we go through. So here's our first one. So I'll give you some time. How many ways could we have a gold, silver, and bronze medalist in the 100 butterfly in the Olympics out of 74 swimmers? So this is a very real situation. We're at the Olympics. We have 74 people in this same race wanting to win one of the top 3 prizes. Obviously, everyone's trying to get the gold. Okay, so coming in silver is still good, but obviously everyone's wanting that specific gold medal. So the debate is, does the order of these 3 winners matter? Just like I said, because everyone's wanting a specific prize, it's going to make a difference if I come in 3rd or 1st, if I get a bronze versus a gold medal. So in this case, because the prizes are different and top 3 don't get the same exact prize, the order does matter. So this is a permutation problem. The first number that you put in is always the bigger number. It's the total number of objects or people or items, whatever you're dealing with. The second number is how many you're choosing out of that total group. So if you get your calculators, there are many, many ways to do this. 388,944 different ways that those top 3 medalists could be placed. Now, if you were at a family reunion and you're doing the 3-legged race and the top 5 people are going to get a piece of candy, the way that those 5 people get selected does not matter what order you finish the race, because all 5 people are going to get the exact same thing. So that would be a situation where order does not matter. Because the prizes are different, the order is going to matter. Let's look at the next one. How many different ways can you create a 2-topping pizza if there are 11 choices on the menu? So we'll write that down quick. So like I said before, when I was talking about all of the other food options, some of you may argue that it makes a difference if the pepperoni is on the top or on the bottom, a sausage, whatever. It's still the same sausage and pepperoni pizza. So because the order does not matter, we're going to use C. We have 11 here, and you're choosing 2 of those 11 options. Putting that in your calculator tells you that there are 55 different pizzas that you can make if there's 11 choices and you get to have 2 toppings. Last one. We want to know, how many ways can you read 4 books over the summer from Miss Tiedemann's top 10 list of fiction novels? So again, after you read your problem, your first question to yourself is, Does the order matter? And then you specifically relate it to the problem. Does the order that I read my 4 books that I pick out, does the order that I read them matter to Miss Tiedemann? No, it does not. Okay, you get to pick any 4 books from her top 10 list, and you just have to read them over the summer. The order that you read them in is not going to change your life in any way, shape, or form. So that is another combination problem. There are 10 books to pick from, and you get to pick 4 of those books. And you get 210. So the homework is just scenarios just like this. And as soon as you lock in and decide on, okay, combination versus permutation, it's a very easy process. You're just putting them in your calculator. You really have to think about them, but don't overthink them. That's my biggest advice to you. Do not overthink the problems. Try to figure out, is the order going to matter? Is it not?